Hey, another example for you guys from 4.5 rational functions. Again, whenever you're given this type of problem in my math lab, you'll be selecting from, say, 4 different graphs that you have to pick the correct graph from. So what I'm showing you is how to find the critical information to be able to discern which graph represents the given rational function. So the first thing that I'm going to do is look at my vertical asymptotes. And to do that, I look at my denominator. So I use the denom for that. X squared minus x equals 0. Factor out an x, I'm left with x minus 1. So I have x equals 0 and x minus 1 equals 0. So x equals 0 and x equals 1. And those two will be my vertical asymptotes. Next, I look at the horizontal asymptotes, and there are none. There are no horizontal asymptotes. Remember rule 3. Okay, but there is an oblique because my numerator is 1 greater than in degree is 1 greater than the denominator. So for my oblique asymptote, and then right here what I'll turn around and say is that you have to divide. So I end up with whoops, almost got ahead of myself there. I have to put in a spacer because I do not have an x squared value. Alright, go in there x and x cubed minus x squared, so subtract everything, meaning flip the signs. And I'm left with x squared minus 4x. So plus 1 gives me x squared minus x. Minus plus negative 3x. But what do we need? We just need the quotient. We need the quotient x plus 1. And that's what I'm going to look at. The remainder and the divisor are not needed. That is my equation for my oblique asymptote. Next, let's see, I can look at the zeros of the function. Zeros of the function. I use the numerator for this. X cubed minus 4x equals 0. I factor out an x. And if we'll notice something here, I had the same factor and the same 0. We have the same factor right here and right here. So that means x equals 0 is not a vertical asymptote. It is a discontinuity. And it is x and then something else, and then we'll have to be able to plug in and see. We can be able to look at that. So that right there is important. So I only have 2 zeros of the function, 2 places across the x-axis, and I only have 1 vertical asymptote. and this here is a discontinuity. Remember, discontinuity, there's my graph, and then I just have an open circle. And again, Desmos won't show that, it'll show just the graph of it. Let's see, let's find the y-intercept, and that simply means to plug in for f of x. And if you notice, I have no constants, so everything will just go to 0. So my y-intercept is 0, 0, and this is 2, comma 0, and this is negative 2, comma 0. And these are points. That's a point. It's equation. And this here is an equation. Vertical line. Okay, the other thing that I can do is that I can look at my factors and factor out common factors from my rational function to help me be able to look at or give me a better idea, and I've already factored them. So for my zeros, that is squared minus 4, and then for my vertical asymptote, those zeros, that's x and x minus 1. So what I'm looking at is f of x, x minus 1. And then I need to look at some points. Again, I've used Excel to turn around and be able to figure out, but remember, pick you a series of points and be able to look at it. Okay, so there's our basic information for what we need. Let me highlight this. I need my y-intercept also. Okay, so those are the critical things that I need to be able to look at on my graph that's given to me. Of course, I didn't make a graph, so what we're going to do is we're going to look at it on Desmos. All right, let me get rid of these. Okay, so this is my rational function in blue. This is my vertical asymptote at x equals 1, and this is my oblique asymptote at y equals x plus 1. Again, I have created points, okay? What is missing on this graph is the discontinuity for whenever x equals 0. We can look up here and we can see the value for y is 4. Again, just to point out, for instance, with the asymptote, is that as we turn around and approach, so let's see here, we're at 1/2 and then we're going closer to 1. So at x is 1/2 and we're getting, there's 1/2 right there, and we're going toward 1. You can see that we're going up on this side of the rational function, and it is going toward positive infinity. See how my numbers just keep getting larger and larger? And then once we passed x equals 1, now we're on this side, and we're slowly going, whoop, there shouldn't be a negative there. As we're slowly going toward 2, you can look at it and see we were all the way down here at negative infinity, and we're slowly approaching up, and we're heading to 2. 2 is the 0. Okay, so you'll use those points to be able to discern and pick out which graph is correct for the given rational function, just by finding the critical data like we did. Alright guys, please continue to critically think and structure your work. Watch your publisher's videos, and good luck with the rest of your homework.